Now we come to the session 36. In the previous sessions, we know the method of calculating the Newton-Gregory forward interpolations formula. We are taking one or two problems, finding the initial, if we given two interval to find the values of x. If we given the x values, we can find the numbers between the x value or corresponding f of x values, average value. Now, suppose we give the in the terminal points and the end intervals. What's the method to find the in the back by using a Newton-Gregory backward interpolations formula? So, in the previous slide, I already know the formula Newton-Gregory backward interpolations formula. See, let the function y equal to f of x takes the values y0, y1, y2, etc. corresponding to the values of x0, x0 plus h, x0 plus 2h, etc. of x. Suppose it is required to evaluate f of x for x equal to xn plus ph. You are observe this formula x equal to x0 plus ph, x0, xn plus ph, x equal to xn plus ph. Here xn we take end values, but in the previous forward interpolation formula x we can take x0 plus ph, where take x should be initial value, but in the backward interpolation formula x should be equal to xn plus ph. The x value should be take end where in the starting should be end form. So that is there, x should be equal to xn plus ph, where p is any real number. Then we have yp equal to f of xn plus ph. Again, you come to the want to convert in the shift e form. E want to convert a shifting operator p e raised to p f of xn. Secondly, here p is minus p here. So e raised to minus p f of xn. So suddenly we are substituting in the backward differences formula. So backward means what e can be written 1 minus reverse delta is old raised to minus p yn. So I'm substituting here. So I'm reversing formula. So e should be equal to 1 minus backward delta old raised to inverse 1. P is there minus. So 1 minus delta old raised to minus p yn. So this is a formula. See, you are observing. So y p equal to f of xn plus ph. So I'm come to the e operating using the formula e raised to p f of xn. So you know by using shifting operator e should be equal to 1 minus delta whole raised to minus 1. So p or 1 minus backward delta whole raised to minus p yn. So complete by using the binomial expansion formula 1 minus backward delta whole raised to p is 1 plus p delta plus p into p plus 1 by 2 factorial delta square plus p into p plus 1 p plus 2 divided by 3 factorial delta cube plus etc. of yn. Open this bracket, we get yn plus p delta yn plus p into p plus 1 by 2 factorial delta square yn plus p into p plus 1 p plus 2 divided by 3 factorial delta cube yn plus etc. Call this equation as C. This is called Newton-Gregory backward interpolations formula. See, we are observing here. What is the difference between forward and backward differences? This formula is used for interpolating the values of phi near the end of the set of the tabulated values. Near the end of the set of the tabulated values, and also for extrapolating values of phi is a little ahead up to the right of yn. Secondly, Newton-Gregory forward backward interpolations formulae are also called Newton forward backward interpolations formula. See, I take a simple example. Say, estimate f of 7.5 from the tables. We come to the tables. X is given 1, 2, 3, 4, 5, 6, 7, 8. Corresponding values of x is given. F of x is given. F of x is 1, 8, 27, 64, 125, 216, 343, 512. What is the if you want to find 7.9 nearly the end of the tables, suddenly 7 and 8. The values of 7.5 lies between 7 and 8. So suddenly we are fine. By using the, so take a tables, the values to be estimated 7.5 near to the end of the tables. Therefore, we use the Newton backward interpolation formula. So, yeah, x and y table. So, difference table is x is given 1, 2, 3, 4, 5, 6, 7, 8. Corresponding values of y is, if x is 1, 2 is 8, 3 is 27, 4 is 64, 5 is 125, 6 is 216, 7 is 343, 8 is 512. Take a first difference, delta y naught should be equal to 8 minus 1 is 7. Delta y naught, so 27 minus 8 is 19. 64 minus 27 is 37. 125 minus 64 is 61. 216 minus 125 is 91. 343 minus this 128. 512 minus 343, 168. See, observe the end of the table. Observe the bottom of the column, bottom of the every column. See, 169. Again, take a difference. Del square y naught should be 19 minus 7 is 12. 37 minus 19 is 18. 61 minus 37 is 24. 91 minus 61 should be 30. 127 minus 91 is 36. 169 minus 127 is 42. Again, take del cube y naught should be 18 minus 6. 18 minus 12 is 6. 24 minus 18 is 6. 30 minus 24 is 6. 36 minus 30 is 6. 42 minus 32 is 6. 36 is 6. So this difference is eliminated. So you come to this. So end of this the table. So xn should be equal to 8. So what you want to find is 7.5. X should be equal to 7.5. The difference at the interval should be is h is 1. The difference interval should be h is 1. So end of this table, yn should be equal to 512. Now delta yn should be equal to 169. See, del naught yn should be equal to 169. Del square yn naught is equal to 42. Del square yn should be equal to, del cube yn should be equal to 6. Del raised to 4 yn should be equal to 0, etc. Now I come to the p to find the values. So p equal to x minus xn divided by h. So x is given 7.5 minus xn should be 8 by the intervals, difference interval should be 1. 7.5 minus 8 divided by 1 should be minus 0.5. Now come to the backward difference formula. So f of x equal to yn plus p delta yn plus p into p plus 1 divided by 2 factorial del square yn plus p into p plus 1 p plus 2 divided by 3 factorial del cube yn plus etc. Now substituting the values, now we get, so yn p delta yn. So substituting the value, so 512 plus of minus of 0.5, 169 plus minus 5 of, again of substituting p plus 1, 2 factorial del square yn is given 42. Substituting by using the suitable calculator, we get f of 7.5 is equal to 421.87. 421.87. Suddenly this value lies between 343 and 512. Suddenly this is end of the interval. Suddenly this value 7 and 8, corresponding value 343, 512. Suddenly this value lies between 343, 512. This is the way to calculate by Newton backward interpolation formula, by using Newton backward interpolation formula. Similarly, we can one more problems. From the following data, see, find the theta at x equal to 84. So x is given 40, 50, 60, 70, 80, 90, 40. So theta corresponding values of x, theta should be 184, 204, 50. If 60, 226. If 70, 250, 80, 276, 90, 304. To find the values of theta at x equal to 84, So where is the 84? Certainly lies between 80 and 90. 80 and 90. Certainly end of the tables. So x is 84. Use the Newton backward interpolation formula as it lies to be end of the tables. So take a difference, take a formula, the tables, put a table form. For x should be, corresponding x should be 40, 50, 60, 70, 80, 90. Corresponding values of theta should be equal to 40 should be 184, 50 is 204, 60 is 226, 70 is 250, 80 is 276, 90 is 304. The corresponding delta not theta. So suddenly take a difference 204 minus 184. So it will be 20. 226 minus 204 is 22. 250 minus 226 is 24. 276 minus 250 is 26. 304 minus 276 is 28. So del square theta should be, take this difference, 22 minus 20 is 2, 24 minus 22 is 2, 26 minus 24 is 2, again 28 minus 26 is 2. So you observe the bottom of the columns every. This is the way yn delta n theta yn. So del square n theta to end of this. So xn is end of this, xn should be 90, x is given 84, h the interval should be 10 because 40, 50, 60, the interval should be 10. So yn should be equal to 304, delta yn should be equal to 28, del square yn should be equal to 2, del cube yn should be 0, delta 4 yn should be equal to 0. Now to find out p values, so p is equal to x minus xn divided by h. So x is given 84 minus 90, so divided by 10, so minus 6 by 10, suddenly minus 0.6. Now substituting the formula, f of x equal to yn plus p delta yn plus p into p plus 1 by 2 factor del square yn plus p into p plus 1 p plus 2 by 3 factor del cube yn plus etc. So some substituting by suitable values, yn you know, p we know, delta yn you know, p you know, del square yn you know. So totally we get 286.96. This is the value suddenly lies between 80 and 90. Means 276 to 304. Suddenly this value lies between 276 and 304. So similarly we can come to the one more problems. Find the polynomial. If we give the point, we can find a polynomial. Find a polynomial of degree 2 which takes the values x is 0, 1, 2, 3, 4, 5, 6, 7. So corresponding values y should be 1, 2, 4, 7, 11, 16, 22 and 29. So if x equal to 1, corresponding values of y is 1. If x equal to 1, corresponding values of y equal to. If x is 2, corresponding values of y is 4. X is 3, 7, correct, right. So if we put a table, so x 0, 1, 2, 3, 4, 5, 6, 7. Corresponding value y should be equal to 1, 2, 4, 7, 11, 16, 22, 27. Take this difference, delta y should be equal to 2 minus 1 is 1, 4 minus 2 is 2, 7 minus 4 is 3, 11 minus 7 is 4, 16 minus 11 is 5, 22 minus 16 is 6, 29 minus 22 is 7. The corresponding this table should be equal to all the game. 2 minus 1 is 1, 3 minus 1 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1, 7 minus 6 is 1. Del q y should be, is difference should be 0. So we come to formula. P, you know, this is p equal to x minus xn divided by h. X you don't know, put the value. You know, express in terms of polynomial, no? So we not given the values of it. So x minus xn should be equal to 7. Divided by 1, the interval should be 1. So suddenly x minus 7. P should be x minus 7. Now come to the formula. Newton Newton backward difference formula. F of x equal to yn plus p delta yn plus p into p plus 1 by 2 factorial del square yn. So substituting because it's only is given degree 2. So enough for del square yn. Only because degree is needed second degree is enough for del square. So substituting. Yn should be equal to 29 plus p should be x minus 7 So into delta yn should be 7, substituting x minus 7 plus 1 divided by 2 factorial is 2 into yn. Y delta square y should be 1. So open, we get 29 plus 7x minus 49 again plus 7 minus x minus 7 x minus 6 divided by 2. Again simplifying, we get f of x equal to 1 by 2 times of x square plus x plus 2. So this is the way we can find. In the given, we don't is not given the values of x, we can express in form of a polynomial. Generally, so delta we can write. So if you put x should be a 4. If you put x should be a 4. So similarly we come to the one more problems. So we know the method of finding the polynomial. Suppose we given the values x equal to something value. Now find the cubic polynomial. See, find the cubic polynomial which takes the following values, hence or otherwise evaluate f of 4. See, is given x should be 0, 1, 2, 3. F of x corresponding values of f of x is 1, 2, 1, 10. So difference table to take x naught is 0, 1, 2, 3. So corresponding f of x is 1, 2, 1, 10. So take a difference, delta y should be 2 minus 1, 1 minus 2 should be minus 1, 10 minus 1 is 9. Del square y should be equal to minus 1 minus 1 is minus 2. 9 minus of minus 1 is 10. Del cube y should be equal to 10 minus 2 minus of minus 2 is plus 12. So the interval C, observe the interval 0, 1, 2 h. So 1, 2, 3. So h should be 1. So x naught initial value should be equal to 0. So we can find p equal to x minus x naught divided by h. X we don't know. So x naught should be 0. So h is 1. Suddenly p equal to x. Using forward interpolations formula, because f of c we can find. So f of x equal to y naught plus p delta y naught plus p into p minus 1 by 2 factorial del square y naught plus p into p minus 1 p minus 2 by 3 factorial del cube y naught, etc. See, in the polynomial we not given either x should be in form of in the power. So again we whatever may be either forward or backward, because we can't we express in form of a polynomials. We use any formula, so that is in the either backward or forward interpolations formula. So that is f of x should be equal to 1 plus x into, so substituting the values of p and delta y naught. So f of x equal to 1 plus x into 1 plus x into x minus 1 by 2 factorial of minus 2 plus p is substituting p should be x into x minus 1 x minus 2 by 2 3 factorial is 6 into 12, etc. So suddenly we get, so simplifying here 2 get cancelled, minus we get 12 divided by 6, you get 2, simplifying we get 2x cube minus 7x square plus 6x plus 1, which is the required polynomial. To compute f of 4, so put xn should be 3, we end up the form, so that p should be equal to x minus xn divided by h. Suddenly x is 4, xn is 3. So end of this t, here xn is 3, x is 4. So x minus xn divided by h is 1. So 4 minus 3 divided by 1. So suddenly we get values of p equal to 1. Now using backward interpolations formula we get. See, in the backward interpolations, so because f of 4 is out of the table, suddenly end up the tables. So as substituting y4, f of 4 is yn plus p delta yn, using the backward difference, yn plus p delta yn plus p into p plus 1 by 2 factorial del square yn plus p into p plus 1 p plus 2 divided by 3 factorial del cube yn, etc. So yn should be 10, 1 into 9, and substituting all the values, suddenly we get 41. So the same value, if you polynomial, we are getting the polynomial 2x cube minus 7x square plus 6x plus 1. Replace x by 4. F of x equal to 2x cube. See, we are observing the polynomial here, 2x cube minus 7x square plus 6x plus 1. So replace, put x equal to 4. The value should be same. See, verification there. F of x equal to 2x cube minus 7x square plus 6x plus 1. So this is the way. If we express the polynomial, replace in the values of x in the polynomial, the values should be same. We get the values is same. So put x equal to 4, we get f of 4 equal to 41. So this is the way to find the polynomial. If you not in the polynomial way, if you replace x to be some values between the any interval values, suddenly we get the values should be between that intervals.